By simplifying the cloud transformation process, telcos can more easily adopt cloud technologies and take advantage of the many benefits they offer, such as increased agility, scalability, and cost savings. Simplifying the cloud transformation for telecom operators involves reducing the complexity of the migration process and making it easier for them to adapt cloud technologies. For this session, we have Rakuten Symphony's Mehran Hadipour, VP of Business Development Alliances, and Vish Nandhal, VP of Technology Strategy and Ecosystems. And I'm Timon Sloan, General Manager of the Open Networking Foundation. So it's my pleasure to have both of you here with us today. Terrific to have you.
Pleasure to be here.
Yeah. So tell me, Mehran, so I understand that you came from Robin.io as part of the sort of the combination or the acquisition with Rakuten. Happened just exactly a year ago, I think. Is that right?
That's exactly right. Exactly 1 year ago.
Yeah.
Same MWC was announced.
Yeah, so 1 year. So tell me, so 1 year in, my understanding is that Robin.io really brought a lot of orchestration and cloud technologies to the overall solution that Rakuten's been putting together. Is that a fair way of thinking of it?
That's correct. We were acquired for that general purpose. We were running Rakuten's RMI cloud infrastructure and orchestration as a customer. Mm-hmm. And now we are part of Rakuten Symphony, which is providing an entire stack for service providers to deploy cloud and orchestration for telco functions.
Yeah, terrific.
So that's the currently.
And tell me a little bit about your personal role at Rakuten now.
It's been quite exciting, I would say. Outside of just being a very good customer, we really expanded the way we look at the market. The product has evolved significantly based on our experience. I'm deploying a very modern network, all software-wise. Over 300,000 cells are radiating today, all based on Robin technology. And it's been a quite exciting ride.
Okay, terrific. Well, I want to come back to lots of that, but also Vish, first of all, I want to come to you as well. So Dell is here today with us, So tell me about Dell and Dell's relationship with Rakuten.
Yeah, as we look at this whole new telco disaggregation that occurs, that Rakuten has kind of really tried to, develop at a commercial level. Dell is trying to reconstruct some of the old vertically integrated ecosystems into something where people can sell best of breed products into it. And that requires, stable infrastructure. And so Dell is trying to become that standardized layer of performance that's going to underwrite the software that comes from companies like Rakuten and, many other partners that exist.
Right. And so you said something about infrastructure and underlying the software. So I'm really curious about that. Where's the line between the hardware and the software? You've got accelerators and drivers and all kinds of things. I mean, is that an easy question or is that a hard question from your perspective?
Well, I think the vision is meant to be that we're building a telco cloud, and that there is a real abstraction between the underlying hardware and the software that runs on top of it. When you think about how a radio access network works, there needs to be some affinities with the hardware, unfortunately. Yeah. So general purpose processing isn't at the performance cost level where it's practical to deploy on just general purpose. You do need acceleration.
Right.
And so one of the things that Dell has done is work with the community to ensure that, different types of acceleration architectures, whether it's in line with companies like Marvell, whether it's look-aside with Intel and other co-processors, that those architectures exist and can be used in the various types of radio access network platforms that are being released in the industry.
Right. So I guess you put together a platform, and those different accelerators are all optional, but they are needed today for Open RAN. And so in all cases, one form of acceleration tends to be included in the package. Correct?
That's correct.
Yeah.
Now you can, for limited performance, use an x86, and those are perfectly viable. But when you think of all of these different types of application workloads effectively for the radio access network, you realize that something needs to track the resources and be able to deploy them appropriately depending on how you're releasing or how you're architecting a network for a particular outcome. And that's where companies like Robin.io comes in,
right,
and Rakuten comes in, where they put that intelligence in, where they understand where a workload needs to be placed based on the type of service outcomes you're looking for.
Mm-hmm. Okay, sounds good. So Rakuten's putting together a full vertical solution. I guess the industry has been talking about Open RAN and kind of, the grand vision is to mix and match all the different kinds of components, but the reality is that somebody's got to integrate it all together, and Rakuten's been, taking a strategy of acquiring all the pieces, assembling full solutions, and then, taking it to market. Is it right? So, Robin IO used to be kind of selling to a broad market. I presume now, Robin IO is exclusively part of a Rakuten solution, or do you still pursue kind of just selling Robin IO pieces?
Not entirely. I mean, Robin, although we started our journey in enterprise, we're now very much focused on enabling softwareization and disaggregation of a telco stack.
Right.
So we are actually selling on cloud on onboarding variety of network functions, not just Rakuten's RAN core and so on. And we build the underlying infrastructure to take advantage of the technologies from Dell and others, that including acceleration, new CPU resources and so on, and be able to build an automation layer that can deploy network services on top of them, zero touch from the deployment on the field all the way to service.
I see.
So we actually enabling this whole softwareization journey, taking advantage of the underlying hardware, and onboarding both VNFs and CNFs from different network function providers to build a telco stack and then do lifecycle operations for that telco stack.
I see. So does that mean, from your perspective, sort of the Rakuten Symphony stack is sort of one option, but you still would consider and engage in kind of other options, custom options for others?
Of course, even the Rakuten Symphony stack is very much open, right?
Yeah.
The SymWorld platform, for example, is operational for a number of network service delivery. The Open RAN platform, the Altiostar product, is a RAN solution, but we can provide a cloud to run any network function and any services.
But but I still think of Rakuten as really selling a pretty vertically integrated solution today. I mean, it's really sort of Altiostar RAN on up the stack. Is that a fair way to think of it, or not so much?
Not anymore, I don't think, because if you think about the different divisions, there are 5 divisions in Rakuten. We all kind of have our own go-to-market and revenue drivers. Obviously, the integration has value, right? What we've done with RMI and the work we've done to create entire working stack is very useful. So we'll have to go to the operators and sell them the entire thing if they buy it. But that hasn't been really the objective of the division. We're all pursuing selling our own component, especially in brownfield, because most of the operators today are brownfield deployments. So you might not be ready for Open RAN, but you could be ready for OSS.
Okay.
You might want to have a cloud requirement, but you're not ready to deploy RAN. So we want to win no matter what.
Oh, got it.
Accounts.
Yeah, and each of these 5 business units has to be profitable on its own and has the license to be able to go after.
And we are measured as such.
Yeah. Okay. Good. Thank you. That helps me understand. Yeah. Fish, it looks like you wanted to jump in. And if not, then tell me how Dell then plays. So I understand there's a partnership, maybe even a bi-directional partnership between Rakuten and Dell. Maybe you could describe that a little for me.
Yeah. Dell's vision is that we don't want to replicate these vertically integrated proprietary stovepipes that existed before. And Open RAN has that as a vision where they've standardized on the interfaces. The limitation has been that there's still proprietary levels of integration that occurs in these because you need a system level outcome. There needs to be cross-layer optimization, and that requires typically a lot of fine-tuning. That's not really specified in the spirit of the standards coming from Open RAN and others. So what we're seeing is that reference architectures are starting to come into play, and that's helping to reduce the fragmentation that we see in the industry, or the possible fragmentation that can come out. There's reference architectures from Rakuten, Mavenir, JMA. There's a number of different players in the field, and the question is how do we make different products and functions interoperable with those reference architectures so that there's communities that can support them, as opposed to just one single vendor that sells all the components.
Right.
And that's the proposition that we're buying into. So for Dell, we know that we need to be able to surface some of these building blocks. We need to be able to pull and support some of these reference architectures. And we need to be able to certify and bring in some of these third-party product vendors so that they can be part of those reference architecture communities.
Right. lots of moving parts.
There's a lot of moving parts.
The industry is really struggling with this right now. We're
They
kind
are.
of, the last year or 6 months or so, integration and verification testing has been sort of a top topic across the industry. So what are sort of Dell's unique attributes, that you're bringing to the table to help solve this?
Yeah, well, there's a couple. Dell is obviously a large company that has a massive service arm. We've obviously had to build that as part of the data center infrastructure support that we give to a lot of our enterprise customers. And so that's underwriting our ability to kind of take on the challenge of building out these reference architectures and doing the integration certification in our labs.
Right.
We have created a structure where we've built out a number of these open telecom labs. Our home base is in Austin, and we're using those to effectively provide the end-to-end integration for companies like Rakuten, for telcos like Dish,
Right.
and Vodafone. So that's the first piece. The second is that, as we're starting to embrace more of these concepts of telco cloud and the disaggregation, you're starting to move towards that commodity layer of performance that hopefully will, bring some of the same data center economics to telco as we've had in the enterprise data center.
Right.
And that really is a function of the Dell supply chain. Being able to apply those economies of scale and the vast manufacturing capabilities that Dell has to drive those same economics into the telco layer is, really the secret sauce that we're bringing to the industry.
Right. Sounds good. Did you have something to add?
I wanted to kind of echo a little more about the key advantage of this. I mean, we're moving from a homogeneous deployment of network services into a totally segregated standard off-the-shelf equipment and so on, but doesn't remove the unique requirement of applications such as RAN and core for hardware services that are required. And the question becomes, then how do you create this integrated stack using a standard x86 platform, and how do you manage them? And the reference architecture is a great step as a beginning to make sure that everything runs correctly.
Right.
Beside that, we actually, for example, on our zero-touch provisioning, use Dell's APIs for Redfish to actually provision a piece of hardware on the far edge at the point of connection without nothing on it, operating system configuration, FPGA configuration, operating system setup, Kubernetes on top, network function services, zero-touch provision, all the way to the service. And that's what makes the economics work for x86 deployment's entire stack.
Right.
If you have to do anything manually, there's not enough people in the country
Right.
to go do 300,000 cells, right? We managed 300,000 cells in Rakuten Mobile with 200 people. So that requires end-to-end automation, and automation is a key part. And the partnership with hardware is a very important part, because you need to provision the right resources for the right network function and do it automatically, and also provision the hardware to the point that you can run services on top.
Right. So how does it work? So it's actually you plug in an RU to a DU, and that kicks off the whole provisioning, process.
It's actually a remote volume. You basically have a profile for any piece of hardware that you're deploying in our orchestrator. The orchestrator understands this is a Dell platform XYZ. It is intended to run a DU workload, intended to run a CU workload. It's going to run a core workload. It would configure the hardware automatically at scale, centrally, with all the appropriate stack, including real-time kernel configuration, Kubernetes configuration to adopt the network services,
Right.
and then deploy network services on top.
Right.
And it does that from at scale without touch. So we can do zero-touch provisioning of using all the Redfish APIs that Dell provides. It also plumb the whole environment for observability. So
Right.
we know what's working, what is a network function stack, if the LAN connection fails. All of that is also plumbed in the time of deployment.
Right.
So
And then what about, so that's kind of initial provisioning, day 0, day 1, So what about day N and sort of CI/CD?
which is actually the bigger challenge,
Yeah.
right? Because you're now looking at things like end-to-end observability of the stack, hardware all the way up.
Yeah.
You're looking at doing that across not one site, but many, many sites, DU, CU, and in their entire core. And our orchestrator actually has KPI level actions for scaling automation, healing automation, even power management,
Right.
which is all centralized. You have a slow environment, you don't need all your resources, you can power down the servers running
Right.
EU. You want more workload on a CU, we can provision new Kubernetes pod to run more CU workload.
Right.
And do all of that through APIs automatically using the orchestrator.
So what about in-service software upgrade? Like, or let me, upgrading the DU version out in the field. What does that look like?
So that's a great problem that we have to solve, right? Think of it, because it's not a homogeneous platform that you never change, right?
Yeah.
This is a server. And think about your iPhone, how many times you get updates. So how do you, for example, realize that I have a Dell platform sitting at the edge, it needs to have a BIOS upgrade because we just found a security vulnerability.
All right.
In our orchestrator, we know exactly where that server is deployed, what model it is, what upgrade should be applied, and we have a workflow to apply updates to all of them in parallel. We can add 25,000 updates concurrently and upgrade all those environments automatically.
Right.
Not only on the BIOS level, but also on the operating system level, on Kubernetes itself, and the network functions. You can put a new network function level software in place in the repository. We know exactly based on that as-built inventory, where is that installed, and automate an upgrade process across them.
But I guess you don't have the ambition to keep the network live. You do that in the maintenance window today. So you would do a software updates or BIOS updates.
We can do a rolling upgrade. We can do an on-prem upgrade. We can shut down one node and transfer it to the other and bring the other node up. All those things are automated. It depends if the network function, for example, accommodates rolling upgrade. We can bring one pod down, upgrade that pod, and then add it to the cluster and do it until everything is up.
Yeah, very good. And so how similar is this, what you've described? So, so Rakuten has their stack, their solution that's being deployed widely in Japan, So how similar is the commercial offering to that blueprint, if lack of a better term?
As far as the blueprint, in terms of the infrastructure level blueprint,
I guess I'm thinking across the board. I was thinking, what AltioStar ran all the way up through the CU, CU, that's AltioStar, but then all the way up through the orchestration and the automation. How similar is the commercial Symphony offering to what's deployed?
It's quite similar. You can buy that entire automation stack if you wanted to on a greenfield environment. We already have that deployment going on in one operator.
Right.
Entire similar stack. Obviously, the requirement on the service delivery would differ. The 4G, 5G, 3G, 2G, whatever they're trying to do, right?
Right.
So there are always differences, right?
Yes, right. I guess that's the nature of telco.
As far as the cloud and orchestration is entirely integrated stack. But
it's entirely
integrated stack,
integrated,
including OSS layer and BSS layer and RAN and hardware and so on. But you can adopt multiple different network functions,
right?
Even VNFs on our cloud, and create your own stack, keeping the orchestration infrastructure the same.
Right. Okay, good.
And keeping the cloud infrastructure the same.
So let me ask you both then about sort of the intersection of public cloud and Open RAN and all these cloud technologies. So, and what you've described really sounds like Rakuten's deploying, a private cloud that's dedicated for this workload and this use case, this application. But others are starting to leverage public cloud for maybe the CU and up as of today. So, are you seeing, interest in that or traction in that direction?
Sorry, I can make it start and you can maybe follow.
Yeah.
We do see interest in public cloud. We see it on two aspects. One, on edge service delivery. They would generally a public cloud play, including the orchestration management usually can run on public cloud. We don't see DU in a public cloud play for DU, but CU up, I think public cloud is a definite. Our cloud platform can run on any public cloud. Even one of the public cloud providers uses our storage layer as a standard default for that public cloud. So we actually have relationships with public cloud providers, and the platform is available as a platform on public cloud in the marketplace.
I see. So you'd blend the storage layer coming from a public cloud provider. Is that what you're saying?
No, our storage layer is used by the public cloud.
I see. Okay, I have it backwards. Okay,
as a Kubernetes storage.
Okay.
So we have a relationship with the public cloud providers. So we can, an orchestrator can orchestrate workload that are hybrid cloud. So you can have certain component of the network stack on public cloud, DU running on far edge on bare metal,
Right.
and create a network service entirely end-to-end
Perfect.
using the orchestrator.
And so Vish, maybe Dell's perspective on, where's the intersection with public cloud and Dell's play in this space?
Yeah, I mean, there's a threshold in terms of performance and latency that helps to delimit where you can run certain functions in a public cloud, where you may have to run certain functions natively closer to where the radio and the RF source is. So, a good example would be something like being able to do channel estimation. There's a certain timing and coherence interval to read what the estimate of a particular path looks like so that you can set up your scheduler and put out the right modulation encoding and then eject that onto the airwaves.
Right.
If you have to transit 80 milliseconds of delay all the way to a public cloud, then clearly that's not a tenable, architecture. So a lot of it has to do with where do you draw that performance layer? Can you draw that in the CU? For certain user plane functions, it may actually be, not an appropriate place to put it, particularly if you're doing local breakout and you have latency to an application that it has to run to a particular consumer. You may not want to hairpin all the way through a public cloud to do
Right.
that. So a lot of this is yes, but I think where most of the community would probably have, a consensus is from the packet core. There makes a lot of sense for that to be in the public cloud.
Right.
OSS, BSS functions, for the most part, makes a lot of sense to have that in the public
Right.
cloud. When you kind of overlay that on top of the economics of a radio access network, the economics are largely in the baseband processing and in the RU.
Right.
So while it's convenient for the service providers to have functions deployed in the public cloud, in terms of addressing where their cost issue is in terms of capital,
Right.
that's still being addressed by, standalone DUs and radios.
Yes.
And, that's where we really, as an industry, need to be able to understand how are we driving that down. And that's obviously where Open RAN commodity equipment comes into play.
Yeah, that makes a lot of sense. And it's kind of like the intersection point is kind of the CU, the question of whether the CU makes sense in the public cloud
That's
or in
right.
private, and we have different people doing it in different ways that
Correct.
we're early in the life cycle of this whole thing. So that makes a lot of sense. So I guess the other part of this is an edge cloud, and public cloud providers, of course, all have their own specialized edges, and and even going directly after the operator space. And they would argue that yes, put the CU, but we'll deliver an edge. Maybe even put your UPF function on that edge, but push that edge close to the user, so you don't have 80 milliseconds. You have whatever 20 millisecond kind of round trip time. But the jury's out on this one, and this is really kind of where. It's unclear yet how things are going to land, but I wonder if that, what you think about that.
So the edge clouds that are coming out, could they host a user plane function? I think that there is probably a lot of mythology around what a user plane function is. A lot of people believe it's just an IP layer,
Right.
Which it clearly isn't. To the extent that we can do control and user plane separation, it's really limited by the fact that user plane function on the data side is tethered to the mobility functions that occur on the control plane.
Right.
And so to the extent that that's true, there's always going to be some limitation of just using a standard IP router. You're going to need a standard IP router that actually understands mobility, and that doesn't exist today.
Right.
And so, when you think of the hardware resources that come native from a public cloud player, it's not really footing the bill exactly.
Yeah.
And so some level of specialization is required, and that's usually where a company like Dell can step in, because we're not trying to create a homogeneous fleet
Right.
of general purpose processors. We're looking for the right type of hardware appliance that's required for the job.
Yeah. Makes sense. Well, this is really going to be an interesting year, I think, ahead of us, or maybe 2 or 3, 4 years. Open RAN is clearly still a very, very hot topic, but there are a lot of questions to be answered, a lot of different deployment models, a lot of different profiles, blueprints, and scenarios. So thank you both very much for joining us here today. This was really a great discussion and great topic.
Great.
Thank
Thank you
you.
very much.